now here's the project. Now on the project, I changed some of the questions. Well, I changed the numbers, but did the same questions, okay? Okay, so it says this commuter airline serves 4 cities, Ashton, Brady, Colfax, and Dumas. Okay, so those are A, B, C, and D based on their names. Okay, the solid lines in the figure show the airline's existing routes. So right now, to get from A to C, you have to fly from A to B and then B to C. The airline is building a new airport at H so that you can go from A to H to C and go straight through rather than having to fly around to B. Okay? And it says this will add 4 new routes. Currently, travelers who want to go from Ashton to Colfax, so here's Ashton and here's Colfax. Right now they have to fly over to B and then down to C. Okay? After the airport is built, they'll fly from Ashton to the new airport and then to Colfax. So the distance will be straight from A to C. How many miles to the nearest tenth of a mile will this save compared to the distance of the current trip? So first thing we need to find out is how far are they traveling right now? What distance is it right now? So right now it's 300 miles from A to B. Well, we need to use the things we learned in this lesson. So they're going to have some of those triangles we talked about. Notice right here, if I form this triangle, what type is it? I have a 90-degree angle, a 45-degree angle. That means this one has to be 45. So it's a 45, 45, 90. This side is AB. This is one of my legs. Here is my hypotenuse. Here is my other leg. So in a 45, 45, 90, what do we know about the 2 legs? If this one's 300, what's this one going to be for a 45, 45, 90 triangle? It's 300. Yep, the legs are congruent. So let's find the distance right now. Right now, if you fly, you have to go from A to B and then B to C. So your total distance right now is 300 plus another 300, or 600 miles. Okay? That's my now. Then we'll have our later. Our later is after this new airport's built. What's the distance going to be? So instead of going around, we want the distance straight from A to C, which notice that's the hypotenuse of our triangle. And in a 45, 45, 90, if you know the leg, how do you find the hypotenuse? So go to your notes for 45, 45, 90, and what do you do to find the length of the hypotenuse if you know one of the legs? Very good. It's the leg times the square root of 2. We know the leg is 300. Multiply it by the square root of 2. Again, just use your calculator for that because they want us to round our answers to the nearest tenth. So just take 300 times the square root of 2. Good. 424, and it looks like 0.3. All right, so if they build that new airport, how much distance are you going to save? So the amount saved would be the old distance of 600 miles. That's what you used to have to travel. Now you only have to travel 424.3. So the distance saved would be, we just subtract those two and find the difference. Okay, so how much distance did they save? Good, 175.7 miles. All right, so again, it's an application question, but we're still using our special right triangles. Okay, project question number 2 has the same scenario. Okay, so we still have these airports. We're trying to build a new one so we can go straight across. This one says, currently travelers who want to go from Brady to Dumas, so here's Brady and here's Dumas. They have to first fly down to Colfax, and then fly over to Dumas. After it's built, they're going to be able to fly directly from B to D. I'll put that route in blue. So afterwards, they're going to be able to go straight there. How much is that going to save them? So again, we need to find each of these lengths. Well, we know this one is still 300. We figured that out last time. Okay. We also need to find the length here. Notice that not only in this picture do I have 45, 45, 90 triangle, but here in this question, I'm dealing with a 30, 60, 90. Notice this 30-degree angle here, a 90-degree angle here. That makes this a 30, 60, 90 triangle. This is my short leg. Here's my long leg. Okay, so we need to find the total distance, this added to this. So we need to know the length of that long leg. So in a 30, 60, 90 triangle, how do you find the long leg? We're supposed to find short leg first, and nice enough, they gave us the short leg. So now all we have to do is, okay, how do we find the long leg? Well, that's the short leg if we had the hypotenuse, but we have the short leg. They gave that to us. So we just next need to just find the long leg using the short leg. Good. So yeah, you take the short leg times the square root of 3. So our short leg was 300. We're going to multiply that by the square root of 3. And it says round it to the nearest tenth. Good. 519.6. So the distance here is 519.6. So right now, in order to get from Brady to Dumas, you have to go 300 miles plus another 519.6 miles to get there. Okay, so right now, let's find that total right now, and then we'll figure out how much when they get the new airport, what the distance will be. Okay, so right now you have to travel 819.6 miles. Okay. After they get the new airport built, the distance is going to be shorter. Okay. Specifically, it's going to be this distance right here from B down to D. Notice that's the hypotenuse of our 30, 60, 90 triangle. So here, to find that distance, all we need to do is find the length of our hypotenuse. So, again, we look at our notes. In a 30, 60, 90, the hypotenuse is equal to what? Good. The short leg times 2. So what would the short leg times 2 be? Okay, so we look, and here's our short leg was 300. We take that times 2, and we get 600 miles. Okay, so now we answer the question, how much is it going to save them to be able to go just this 600 miles as opposed to going 300 and then another 500? So all we need to do is find the difference between the two distances. Right now it's 819.6, but after they build the airport, it'll be 600. So how much of a distance is that going to save them? Very good. So it'll save them 219.6 miles of traveling once they get that new airport built.